Okay, welcome everybody to the CSU Robotics robot event. As you know, we are doing the EZZY Bot Arm. It was created by the Gizmo, an Italian engineer, a few years ago, back in 2015. I did a few slight changes just to get the parts fitting better, custom housing, wiring, additional Bluetooth, etc. But for the most part, what you find online is pretty much this build, besides a few extra bits. I'm going to go over what this build can do, or what you can expect for the robot. It has 4 servos. It has 3 MG90S servos, which are found in the very base and the size of the arms. Then it has an SG90 servo, which is the same thing, but it's a bit smaller, not as strong. That's on the equipper itself. Each servo can move 180 degrees, so it can go right, left is the most. I'm going with the parts list. I hope everybody has their kits with them, or at least went through it or going to. So I'm going to go through what we have in them. Starting off, these are servos. That's way too close. There we go. These are the servos you have. Like I said, 3 copies, and then a smaller one. You have a total of 21 ribbons. Or sorry, you have 35 jumper cables, 21 male to female, 8 male to male, and then 6 female to female. Then you have your regular USB to your Arduino, and then your jacks cable. Then you have right here, which is your Nano Shield, which goes to your Arduino Nano, just helps connecting the pins and power. You should get both a male and a female power jacks. And you're supposed to have 2 packets of hardware. This one right here, that is all silver parts. That's mostly M3 parts. As you can see down in the slides right here, the M3 hardware packet includes 2 12mm screws, 6 16mm screws, 8 self-locking nuts, only 2 washers, and I included 1 M4 by 25mm dowel. That is this right here, this part. So we can point to it. And you also get a plastic washer, which I added onto the build. Then you go to the other hardware packet, which is the M4. You have 3 M16 screws, 3 20mm. Then you have 1 25mm, and then 1 30. And then of course you have the 8 self-locking nuts, and then you have 11 washers. Everyone should also have 4 10K potentiometers. We just use this to control each servo manually. And what else is in here? I also threw in a HC-05 Bluetooth module. You don't need this for this build we're doing today, but it's additional if you want to later on play with it, if you own code, use your phone, control the robot. It's there for you to experiment with. And just some odds and ends, sticky pads, and then you have the breadboard pin connector for the jumper cables. Besides that, you have a whole box full of parts. To split in 2 parts, you have the main robot housing. Then you also have a custom created power housing. Just mainly a box. You just connected all the wires and the bits. Those are mainly all the parts we have. So I checked all the kits. They should have everything in there. If for some reason I missed something, you can just tell me either through email or whatever, and I'll try to get you the parts so you can finish this. Put this away. I don't need that now. going to the first step. Now, I did recommend getting super glue to help hold in the jumper wires to the potentiometers. I found that they're a bit loose when you try to plug them in. And then if you play with them, they can easily come out, which makes poor connections. So all I did was I put each pin or each jumper, put a dab of super glue here, let it dry for 5 minutes, and then that's fine. I'm going to do all this live right now, actually, so it's a bit easier. Like I said, there's supposed to be 4 potentiometers. For potentiometers, it doesn't really matter which terminal is positive or negative. They alternate. For this, since to make it easier for us, I decided that with the potentiometer facing you, that is this bit towards you and the pins down, the furthest left one will be negative or ground. The middle pin, that's going to be your signal, essentially your analog signal, and the furthest right is going to be positive. To make it easier, if you flip it around, I suggest taking a piece of pencil, if I have one around here, and marking it so it's easier. One moment. Like this. So this facing downwards, it will be the opposite. That furthest right one will be negative, the furthest left one will be positive. I'm here to see the marking by giving, say, a Sharpie or some kind of pen. Try to mark somewhere so you know where it is. It makes it easier connecting the pins later on. For checking cables, we're going to use 2 male to female and then 1 female to female jumper cable per potentiometer. If anyone has questions, just let me know in chat or stop me. I'll try to answer them going too fast. But I'll be doing the pins right now, gluing them, putting them aside, and then continuing afterwards. I found that super glue takes a few minutes to dry. If you touch them, you ruin all your work. Okay, yeah, like I said, I just got Gorilla Glue, fast drying. Starting off, female to male. Come on. Yeah. This is the wrong one. For a slight tighter fit, if you see each pin has a little metal tab, I put them to the side like this. It's just a bit tighter, so it's not as loose. You can see that. The camera's a bit blurry. Versus doing it right side up, it's a bit looser that way.
Andre, is there any way, when you finish that, is there any way for you to make the camera bigger, like the video of you doing that bigger? Shrink the.
Yes, thank you for reminding me.
Okay.
I set this up for a reason. Forgot. That's better.
Thank you.
Just really dab to hold it in, beating it right there. Now try to put them to the side somewhere so it doesn't get knocked over. And then just continue that with each and every one.
Is it necessary to choose any wire, or like we can use any colored wire?
You can use any color really.
Okay.
With the jumpers I gave you, they had a multiple colors. I tried to give you red and black as much as I could. They were just only a limited amount. That's why I mentioned if it's easier to mark on the back where positive and negative would be. For example, this is facing downwards, so negative would be the rightmost, positive will be the leftmost. Like I said, it doesn't matter which one you use for positive or negative. For our code that I gave you, I decided to make that this pin right here will be negative or ground, and the left one will be positive. It just makes it easier when you turn it clockwise, it goes up, turn clockwise goes down. It's kind of that kind of thing. It's convention-wise. But color for pins or jumpers, just do whatever.
Okay, thanks.
Andre, could we also solder those if we wanted a more permanent connection?
You can, yes. I just assume most people don't have solder kits, so I did something easy to get with a super glue from a hardware store.
No, I just wanted to make sure that it wouldn't melt or something.
And now I'm stuck. But if you do solder, just know the plastic bit would melt since the connector is inside of that. You could take off the plastic connector, the housing, completely, and you just be left, camera, where that metal bit is, they'll be exposed. But if you do that, if you do a little movement, you can touch the next pin, next terminal, and then you might have poor signal. Okay, that's the last potentiometer. Leaving that all to the side to dry for later. Now I want to skip ahead for the instruction manual. If you guys have downloaded the Arduino IDE and then the, where am I at? What in the world? Oh, right here. Yeah. If you download the IDE and then the driver I sent you, you can follow along now. I found that it's easier to set each servo to 90 degrees right now instead of doing later after you install it, because depending where the angle of the servo is, you might not get proper movement. So it just makes it easier to install later. So let me open up, close that up, open up all the parts you would need. have just the shield, which looks like this. Pretty basic. Then the nano. It's just like that. And they just connect together. You might need to bend one of these terminals over a little bit. You can see it's slightly bent. That's fine. Lined up? Yes. You just push in. Next part is just take this part to the nano to USB, plug that in, and then you can take this. This will be the same process for all the servos. Just use this one. Now for servos, you have red as your power, brown is your ground, then this orange one, that's going to be a signal or your pulse width modulation signal. Just take some of the no. Yes, take the male to female pin connectors. You just need 3 of them. And you just plug them in to each terminal or each pin. This gives you just more length. It's easier to move around.
What did you attach to the Arduino board?
The Arduino board, now you have the Arduino board right here, the Nano.
Yeah.
Is the small one, and the big one's a shield. It just has extra
Okay.
pin connectors, power. It just makes it easy to use.
Okay, thank you.
Now, if you look at the instruction manual right here, as you see that orange pin or the pulse width modulation that goes to pin 8. For this one, I have that going to white. Is that right? Yes, it is.
Camera.
I have white. That is going into pin 8. There should be a little number. It's the first row closest to the nano. Just plug that in. Can you guys see, or is it a bit too dark?
It's a little too small.
I can switch camera views. I just wanted you to see that.
There we go.
Okay. Yeah.
But I don't know.
yeah.
Do you have a light?
The camera's kind of blurry, so it's hard to see. I can try to increase the brightness. Configure video, brightness.
I mean, it's fine.
Yeah, it's mainly the camera. It's just a shitty old web camera that I had. So if you go base it off the instruction manual I sent you, you should see that all the orange pins goes to 8 right there. Power red is going to 5 volts, which is located right here. It has 5 volts there written. It's going to be the second to right pin, and then ground's right next to that. Sorry for the blurry camera. But continuing, I have red lines going to gray. So that's going to go to the 5 volts right here. And then ground, brown is the black wire. It just goes to ground one next to the 5 volts. If I can get it in. There we go. So that's going to be the same thing for each servo. Only thing you do next is you go to this screen right here, which is just the Arduino IDE. You you should have this code. It's named servo setup in the zip file I sent everyone. Just to make sure everybody knows, you have to have this IDE, and then you have the driver along with this. The Nano I sent everyone is technically an off-brand one, not the authentic Arduino one. So they have to use slightly different driver. You just download that. That should be fine. Setting wise, if it's new, make sure it's set to Arduino Nano, which is found in Arduino EVR boards, and just do Arduino Nano. And then for processor, you want the 18 mega 328. You cannot see this, can you? Why is this screen horrible? Okay, one moment. Let me change that. Display capture, capture display. Let me try to zoom in. There we go. Same from the top. There we go. You want to go to Tools. Make sure you have board Arduino Nano. Is found in Arduino EVR boards, Arduino Nano. Then next, you're going to have the processor. Make sure it's the 18 mega 328 old bootloader. Since it's an op-brand, we use the old one. For ports, you should have COM1 or whatever it is, just before you connect anything. All you need to do is plug in your USB to your Arduino Nano, and then plug that into your computer where you have the IDE in. You should get everything working. Go back to port and whatever the next COM is. For me, it is COM9. If you see in the full camera, it's just gonna look like this. It's all plugged in. Since we're only using one servo per Nano for now, we can just plug it directly. Okay, don't do that. Full camera. You just plug it directly, it won't do too much. The reason we need a separate power supply with the full systems because we have 4 servos, just too much current draw for the single board. But for now, it's fine just doing this.
Question.
Going back to the code right here, you have to do first compile it, which is this check mark.
Andre, there's a question.
Is there?
Mike Moore, you had a
I don't
question?
see anything.
Oh yeah, I was typing it out. Whenever I try
Oh.
to install the driver for this guy, it always gave me an installation error, and I'm not sure.
Really?
Mhm. Is there a
Huh.
specific place I need to put it?
It's showing this to be a regular driver. If you go to, where did I send it?
At the CH340 driver?
Yeah, it's supposed to be that, the CH340 driver.
One second.
Nope. That's the wrong email. I have too many emails. What did I send you guys? There we go. I sent you that. And then I sent you this. It should be just this one.
Yeah, this is the page I went to, and then download that first one.
It should just be an execution of it.
Right, and when I run the installer, it just says it loads up the little menu. I hit install, and then it throws a driver install failure pop up.
I was gonna say I had the same problem. What I did is I literally hit uninstall and then install again. It worked.
You could
That's
try that because I just reinstalled it. Mine working just fine. So I'm not sure.
there we go.
Alright.
Okay, that worked.
Okay,
Andrew, have you
this is working
sent
now.
this code via email? This code that you're portraying right now?
I sent it to a zip file to the
Okay.
email last night. It's
Okay.
named servo setup.
Okay, thank you.
I moved that up. But when you hit the check mark, it's supposed to run it, verifying it. You see in the bottom, it's compiling. You know there's no errors. After that, you just hit, this is annoying, this arrow mark right here, and that'll just upload the code directly to the Arduino Nano. Hit upload, compiling sketch, uploading, uploading complete. You didn't hear it, but it actually turned the servo left to 90 degrees. So it's going with servos. Is it set up like this? Yeah. So right here is 0 degrees. This is 90 and this is 180. So I made sure to turn this 90. So when you install it straight in. Sometimes if you turn it manually without being plugged in, you can have the servo down here or complete opposite. So when you put in the robot, it's trying to turn where the parts won't let it, and you could break the servo. So I do this first, make sure everything's set up. Now you just do the same thing for each servo. Since this one's done, put to the side. Now do it with this one, just the SG91. Same pin setup. Brown is ground, red is power, orange is signal. Make sure you have it all correct when you put it in the Nano one. So in this case, white is going to be the signal, gray is power, black is ground. Then you're supposed to hear a little turning of the gears. That means it's done. I heard this, so this one's good as well. Just unplug it and repeat it for the final 2 servos. Make sure you keep these as well. These are needed for later. I need a bigger disk. Just so you know, you can actually unplug this and plug it back in. It'll download the code to the Nano and it's saved. So you don't have to rerun this constantly. So you just unplug that. Do this now to show you. Once again, white, gray, and black will be your signal, power, and ground, at least in my case. And then this one. I'm trying to hold this up so you can see. There we go. So you heard that, but the gear did turn to 90 degrees. And then just one final one. That's done. Then that's the pre-setup. Next, we're going to move on to I did not read the questions. Sorry. Yes, I selected. Is this the right one? No, it's not. It's this one. I selected the tools. I had the processor as AT Mega 328, the old bootloader Ryan. And then Aaron, for the COM options, it's whatever shows up as you plug in. For example, mine is COM9. If you don't install the driver, you won't see the new COM port. It won't read that. If I unplug the piano, the COM9 will disappear. Or the port. Yeah. If I don't see a question in chat, just speak up. Someone. I have multiple monitors. I don't see everything. Moving on to the very top, the actual building portion. I move everything away, save room. That's done. I don't need this yet. We are going to do this first setup. Explain what each single part is, and then move on to the next one. Are you not seeing a COM port? Okay. I'm starting with the housing unit. It's just 6 parts. Go away. Bottom, top, front, back, and then the sides. That's going to be later after we do the main robot. For the actual robot itself, you have the base, you have the top, which was a turn, the front arm here. This is going to be the gripper. Then you have multiple arms and such. You have 3 copies of these, 2 copies of these. These are the links we're actually going to use for the first step. This is going to be toward the servo arms that just holds the servos to the body. The main arm, another main arm. I already snapped these pieces together for you. It's going to be the left or the rightmost, or is it leftmost? Leftmost gripper, and then its twin right here. These are just going to be part of the main servo. And just some more bits and pieces. For the first part, we're going to need 2 links, and then this piece right here, the triangle one. Let me show you the schematic, what it's going to be. So get out the M4, which is going to be the bag with the black screws. We are going to use the M16s, washers, and then just the nuts. And the M16s, these are the smallest ones we have. They are just going to be the black screws right here. 2 pairs of washers and 2 pairs or a pair of nuts. And I do recommend, if you can, okay, glad to hear that, Mike. That's probably just a refresh thing. Some of these off-brand parts don't always work very well. We just started constructing the parts for the first part of the robot, which is right here. So if you can have your parts out, you just need 2 links, triangle, and then the M4 parts, M4 hardware. We're going to use the M16 screws, the black ones. Starting off, you want, let me move this here so you can see the full view. The other way. You want the triangle link like this. You're going to have this flat piece right here. And the second link also with the flat piece behind right here. So it looks like that. All you do is just put the M16 screws through here, Why are you so tight? And then just put the washers in the hex nut. Now it does kind of get hard to screw in the nuts by hand. That's why I recommend having some hardware. I just have Phillips head. And then for the screws with the M1s, you need a, if you have it, M7 wrenches. This is hard to do by hand. Ignore that. Now, it doesn't need to be ultra tight, but just enough to move around. I can do this actually tighter. This is good. So if anything, just a slight amount of resistance. Did I flip this? No, I did not. Yeah, I did. I did this backwards. Wonderful. Let me redo that then. I wasn't paying attention. It's supposed to be like this. This piece behind the triangle. I did in front. That flat edge towards it, like that, and then screw the damn thing in. That, and then a bit more. It's actually a bit too tight. That's better. Moving on, you just do the next bit right here, which is the same process. Just do 60mm hex to the back, to the next arm link. I did try to drill out the hole so it's a bit bigger. If anything, it's going to force it through. But yeah, it should be like this. And just the same thing, screw it in. Rotating. All right, first bit is done. Moving on, you want to take the third arm link, the long piece, and this smaller piece here. We're actually going to use two M20s, which is the next size up. So the black ones, they're going to be slightly bigger. You only should have a pair of them. Oh, you have three of them. Put this to the side. This arm, this one, this one. and then 2 of them. As you can see in the instruction manual, you have this first arm here going down, having the link right here. So flat edge against it, and then you have this final bit right here, which goes on top. Now you also, for this bottom bit, you have 3 M4 washers in place. That gives a bit more space since it's kind of tight and the designer didn't do the best job of designing it, but it's just version 1. So all in all, you need 5 washers. Yeah. Let me change camera views so you can see. Same with this bit right here. Now you want to go from the bottom upwards. So it's going to be like this. The reason why is this arm is going to be like this when you do it. And you don't, like that. And you don't want the washers getting in the way, the nuts. I have 3 hands. That's good. You shouldn't wobble too much, but still have free movement. Moving on, you want this piece right here to fit on top right here, this link. Once again, you want the, where did it go? Straight one, yes. You want the M20 screw go from the bottom, and then you're gonna put 3 washers. This is just spacing for later. So you have 3 of them right here. Then you place this bit on top of that. Place the final washer on top of that, and you screw it in. So you have a gap like that. You just tighten it up. Bit too tight. That should work. Then you have your next piece in. So far, we did these 2. Those are going to be the main arms. Moving on, we actually got to put them together. Now, all you need to do this is this piece right here. How you do that is I'll zoom in this later, but you put this first piece in, we did first, put this in the first hole, like that. And for the second one, right here, you want this to face inwards. Remember, the heads of each screw are supposed to be facing inwards. And to hold that, we have the M30 screw. Now this is going to be the longest one you have in the M4 packet, which is 30 millimeters. What you do is go through the first bit, flip that. Go from the bottom up. I first put this in. And then you put the second one we did in this hole right there. You can see that. You just feed the M30 all the way through. It's like that. As you can see, the heads will not hit each other. Well, they won't when you play with it. Just do, once again, washer, and then the nut. There we go. I should have free movement in all pieces. Nothing should be difficult to move. Some resistance is fine, like this piece here, it's okay. But for the most part, it should be free movement. Okay. Let me actually zoom in with the camera so you can see a bit better. See it there. Front view. Top view. So now the camera or the robot arm is facing forward. This is going to be your right hand, this is going to be the left hand side. So you can see where the server is going to be here on this side. Turning this up and down, up and down. This one will be forward and back. So it's going to be like that, forward and back. Wow. Okay. Once you have this bit, you go to the next one, which is the base assembly. Now you need this main housing like this, and then you're going to use one of the black servos, the MG90S. Only have 3 pairs of. This one right here. Start off, you put it in the housing with the wires facing toward that way, facing this way. Switch views. So feed it down. Now it should slide in like that. And there's also a little notch in the back where you can feed the wires through. Now using the little bag that comes with this servo, there should be this one. It has the black horns. There should be a small little screw in there, which will help secure the servo. It's going to be this one. You're supposed to have 2 pairs. Switch heads. Now, you don't need to do both screws. In fact, you can't, because the designer, when he did this, left too much of a gap back here for the first screw. So we're going to put it right here. If it's a bit easier, you can actually take either a sharp point or something and try to make a little indent so you can put in the screw. It makes it easier in the end. Let me just screw it in. This is just plastic, so if anything, just push down where you're screwing. It will just have a grip. There you go. Good. Holding. Then you just put this to the side. Moving on. Where is it? We want to do this piece right here. There's the base connected with the bottom rotating portion. We actually going to need the M3 hardware kit now. Put that to the side so I don't lose it. Before I zoom in, once again, these are just the M12 ones. Goes to the top, to the base, and you screw in with just two washers or two hex nuts. That's all. You don't need washers for these. You only have two of them in the kit. That's for the gripper, so don't use them. So let me switch views. Full camera. So they should line up like this. Holes in the bottom. And just fine. These are going to be the smallest ones you have. Are they? Yes. These are the smallest ones you have. So those. Just
Andre?
go to the top. Yep.
The part that you're putting on top of the base right now, I had to kind of countersink that a little bit so it would fit flush.
Oh yeah. I mean, if it's not flush, it's okay. It won't matter too much.
Okay.
All you need is just it to hold when you turn. There are, as you notice here, cutouts for the hex nuts. They don't really fit because the designer made them too small. That's okay. You don't need them to fit. You just need time to hold it as well. Just grab this one. Once again, she got 3 hands. Needs to do it for the second one as well. Okay. Then X. That's complete. It should be pretty tight. As long as it holds, okay. We can put our hardware away for the M3 in a separate pile from the M4 mixed up. Next, what we want to do is get this servo horn. That's going to be the double-ended horn right here. You just place it in the slot. That is, place it right here. It might be a slight tight fit. If you have a pair of scissors or a knife or a actual knife, just carve out a little bit. What I do, well, it's simple, it works pretty well. If it is a bit tight, you can cut off the very ends of the servo horn and just like push it in. Now the directions originally in the designer's instructions, he had us to do a servo horn screw going from the top to the very bottom. I ignore that because the servo horn provided by the servo is too small. It's not long enough. Plus, you don't really need it anyways. And if you want, you can actually take this as is. Let me switch views. And put it on top. Since we already did this 90, it should be fine. Now make note that the arm for the top bit should be facing backwards where the cable is. Since we set the servo to 90 degrees already, that's why it's easy to do it beforehand. He just snips in or pushes in. And he turns. Like that. Next portion. Oh, this is gonna be fun. We are doing the gripper arm next. Now, where's the get the blue servo with the packet, and then all you need is the 2 gripper arms, and then this piece right here. This is just a gear. It goes from the servo to the gears for the grippers. going over the instruction manual, what you have is the main bit here, and then you have the 2 gripper arms with a pair of washers. Those are the 2 M3 washers in the pack. I have found them go between these 2 parts. If you can see my cursor. I found it's easier. Here's just a bit of gap so the plastic doesn't grind against each other. The designer originally had it down here. Ignore these 2 washers, they go on top. You are using the M3 16mm screws. Okay. Those. And this one. These are the parts you're going to need. It doesn't matter which one you do, just one of them. Starting out from this one, let's say, the one that's already snipped together. If you have the M16 or the S16mm going through, put the washer between it, and then you have this right here going up top. So it's like that. As you can see, the washer gives just enough space so it doesn't grind against it. That's a little addition I did. And then all you need from then is then just the hex nut. Favorite part again. Don't make it too tight, since this one does need to turn pretty easily. Still too tight. So not that more. That feels good. Okay, so the next portion, you just slip it in so it's flat like this. Starting off M16 to the bottom, washer, and then you want this one like this. Maybe I'll show this one first. If you haven't started building, I suggest doing this piece first, then this one. As you can see, I have a little trouble slipping it in. Damn. Actually, I'm not gonna do this. Do that first. Okay. Now the next portion, I redo this one. Now the gears should fit pretty snug. You push them in like that. It's gonna be like this. The design is you have this one here attached to the servo on the bottom. So if it moves, turns this gear, turns this one, turns the other one. And so let me just tighten this up. Okay. Now take the blue servo motor, the smaller one. That will go on the very top like this, as you can see. So wire facing outward will look like that. Once again, you just take the packet you have. You're supposed to have 2 screws in. You can use 1 or 2, whatever you want. Since it's kind of hard to screw them in. You're going to have 2 holes. I can zoom in. We can try here on the other side. The back is kind of hard to get. That's why I needed 1 in front, personally. So again, try to make an indent. There we go. And just screw it in. Good. Now the last bit. Now get the clear plastic washer I gave you. Put that first down there. Put that first down there. And then take this piece right here. Make sure that the flat piece, see how it's kind of indented, goes down first. Now the plastic washer, I put it in again as a spacer between these 2 bits. It's kind of, let me turn down the brightness because it's kind of hard to see. What else was I could do? Still horrible. Regardless, that's kind of how the main gripper head works. What you need to do next is put in this head like here. So this going into it like that. And then you screw it in. Before you do that, take a pair of scissors and cut it in half. You don't need the full length of the horn. Got this piece. So fit snug. Last thing you need to do is you have a very small little screw, which you screw in the servo horn to. Make sure the plastic bit doesn't fall out. Like this. Now this is complete. As you can see, opens, closes. Well, that's the gripper head. Anybody has any questions before I move on? Is everything clear? Do you need to repeat anything? All right, I'll move on then. As you can see here, this is just a more detailed view of it. Next bit is connecting the first bolt we did to the main body. It's pretty simple. Let me switch camera views. Camera view. Now to make it easier, I just take this bit off completely. As you can see, the servo horn came off. Make sure it's still 90 degrees. Pull that off. You put that back in when you can. This way so it's kind of flatter instead of rocking back and forth. As you can see, the horns in the back, you want this to be facing you. All that is this main piece goes right here. Like that. And to close that off, all you take is that metal dowel, the metal pin in the M3 packet, and put it through the hole. Like that. There we go. Now push this in as much as you can so it's clear of the space in here where the servo motor will be. Oh, too much, way too much. So it's more or less even. It's gonna look more or less like this in my hand. As you can see where the parts are. Kind of hard to show you. Not completed. Up and forward, up and down. Okay, here's the next bit. This is continuing on with the extra two servos connecting to the main body. I would wait before screwing these pieces in because I find it easier to first put in the servo horns here on both ends, and then like I did the first part, just plug in the servo on top of that. Grab the packet. We're going to use two of these, two of the single servo horns. First put them in, if you can. If they're slightly long or slightly too big, just try to cut them as much as you can. Say just the very tip of it. And then you press it. You do that again on this side right here. This side's a bit difficult because you guys really big hands. It just takes a bit of patience. I cannot grip this. Oh. Again, slightly too big. So just cut off the very tip. See if I can get this in again. No. Just, well, that's just sideways. Infuriating. Oh. Okay. But it will cheat. No cheating. There. So just done that.
Are you on the struggle bus, Andre?
I was for quite a bit. There we go. Now it's all connected. And all the
Yay.
horns are in place. It took me bloody long enough. Now the next bit is pretty simple. What you need is the two servos we have left over there, and then just the M3 kit. You're gonna have 4 M16 screws left over. That and just the 4 washers, or 4 nuts. First, let me switch over camera's views. Where's my mouse, full camera. You take these are gonna hold the servos to the actual body. So the flat end would be going towards it, where the more curved end away from it. Now these are also kind of tight, so you might need to force them in. There we go, that's one. And you have a second one. Come on, just struggle for one. There we go. And there's a second one. Now these are gonna go vertical, like that. Now to do that, first we need to take the M16 screws, and then we go from the bottom inwards, outwards, as you can see there. And I do that for both. This is the same process for both ends. Like that. Now when you put this in, I highly suggest, of course, I would suggest putting the first end here, where you have the extra bed 90 degrees, like that. Since we set the servos for 90 degrees, it will just press in exactly and it will be perfect angle-wise. I just push that in, like so. So it's in the horrible camera view. There, it's gonna be like that, as you can see. And then to connect it, you just do, once again, the 90-degree servos on the back. Make sure you do it from the back outward, so the head's inside and then the nut will be outside. Since these are kind of long, it would block this end from going all the way down. Let me just screw those in. More struggling. On the bright side, we're almost done with the main building. Finished. Okay. Of course. Switch heads. Or bits. I have no idea where to place that. Not that. Well, that would work regardless. Here it is. Okay, let's find a prepper tool. What is this? Will this fit? It might. I found screwing all the parts in to be the most difficult, especially there's very little room. Okay, let's do the other side. Again, from the back outward, then just have be fixed up. You good? That's tight. As you can see, this bit, as the server would move, it would move it up and down. So this would be stationary, like that. Moving the arm up and down. While this back one servo would go forward and back. Let's do the next side, the back. Once again, keep this at 90 degrees, since this is right side 90. You just push it in. And same thing. Have a fun time screen using this one, hex, that. If you get fed up and you only do one of these, that's okay, because they'll still hold. But I'm going to do both, since I might as well. And this will be the last of the M3 kit as well. So we're going to use all the hardware. Only thing left is going to be the M4. Let me do this. Better angle with that. There we go. All set up, mostly. Now you can actually put this together. Don't forget, this arm goes to the back where the wires come out. You just press fit this in. Maybe raise the camera a little bit. Let's move on to the next portion of the design. Yeah, there's only two more left. It's going to be this bottom one, which is this connector to the back arm, and then just putting the head on. That's pretty simple. You just take the M16, which is the black screws, one nut and one hex. Once again, put the head of the screw on the back end, so you tighten it to the other side. Like so. Then you just do a washer, and then the nuts. Not too tight so you can't move it, but tight enough so it's not loose and rattling. Like right now, it's pretty good. If everything moves pretty good, then that's good enough. Bloody wires. Last bit, just taking the head, connecting it right here. If you look at the instruction manual, it is just going to be, the top one is going to be the M20, the bottom one is going to be the M25. So just a long and short one. You only have two left. Once again, just do the washers and the nuts. That's it. Wrong one. Before you do that, I would suggest wiring for the servo through the hole right there, and then putting on the arm. So it'll be underneath it. It's kind of easier managing then. So let me actually do the bottom one first then, the M25. So, and I can also do the next one, M20s. Then you just put in the washer and the nuts. Oh, come on. Now these two screws can actually be pretty tight since this head doesn't actually move itself. Only the gripper does and the arms. So this part will not move up and down. This I mean. And that is. Something's a bit too tight. If you notice that something's a bit difficult to move up and down manually, for example, back and forth, it's easy, but moving the head up and down is hard. That means one of these screws are a bit too tight, so I would loosen them. I think it is this one. Maybe not. Maybe it's this bottom one. Ah, so I lied. Make sure these aren't too tight. I didn't realize you were also moving. So let me just loosen that up. Again, I was wondering why it's so difficult. There we go. Much better. And that is the main robot itself. Next, we're going to do the housing unit, the wiring, etc. Before I do that, does anybody have any questions? So I know it's been a good hour and a half of building.
You're doing good, Andre.
Now this might run over 1 p.m., maybe longer. I'm thinking at most 1:30. If it takes longer, are you guys okay doing the wiring portion later? Because I don't know if anybody has any meetings or other priorities after 1. It's getting pretty late. I want to continue regardless, but I'm going to take that as a go ahead then. All right, then I'm going to put this robot to the side. I'm working on the housing unit. A lot of extra crap I don't need anymore. Useless, useless, useless. Okay, I don't really have slides for the housing unit since that was custom made, and I didn't feel like doing every single wire, and I didn't have a lot of time. So this is going to be just a schematic where the signal wires are connected to. As you can see, there is potentiometer or not potentiometers, servos. You know that orange is signal, red is power, brown is ground. So just from the orange line, it goes to 11, 10, 9, 8. With the Bluetooth, as you can see here, it has ground and power. That's obvious. TX, that goes to pin 1, which is TX labeled on the shield, and then RX is go to 0, which is also RX. If I show you the Bluetooth, if it's visible, there's also, it's not visible at all. Wow. Okay, never mind. But if you have the physical Bluetooth to you can see it's labeled power, ground, TXD, RXD. EN, which is enable, you ignore. State is also you ignore. We don't really need that. Since this is the HC05, this is both sending data and receiving data. Starting off, you have these 6 pieces. This is the base. Easy. Top. Easy. Sides. And then sides again. Let's start off first with the potentiometers. Goes like this. Yes. As you notice, the side pieces are actually angled at 45 degrees. So the pieces fit like a square. Make sure that the angle is inwards when you put it in the base. Let's start with this one, since this is going to be where potentiometers are. It's going to be these 2 pieces, going like that. So grab the potentiometers. If you glue them, they should be dry by now. Yeah, definitely are. If you take out the caps or the knobs, you should also see little washers to screw them down. So you need those. Let's start off with this one. Once again, make sure this angle's inward. So this goes straight in like that. There should be enough room for the little protruding piece to come out. Before you do that, I would suggest bending the pins back a little bit, so it's just a bit easier. What you do is just take the little washer hex thing and just screw it in. Pliers would be useful. I'm an idiot, so I'm going to use my fingers instead. Very difficult. Make sure it's more or less snug. Hasn't be perfect, but just isn't too loose. And then you just put in the cap with the knob, and then you have all the way to the left what the signal is. That's going to be 0, and you turn it all the way to full on. So for example, this is going to be 0 degrees, all the way on is going to be 180. You just repeat for the next 3. So again, bend it back a bit so you have clearance. Make sure the angle is going that way. So you turn this. In other words, the sides facing outside the box, or the face of the box, should be rougher. The inside of the part should be smoother. It's a bit easier to understand. This is so janky. Okay, this one's good. Moving on to the third one. Make sure none of the wires are too loose if you did glue them down like I did. And then make sure they have a good connection. Good. Yep. And then the final one. Connection's good. And okay. Turn the knobs all the way down. And I'll put on the knob caps. Like so. So it will turn out like this when you put it in the box. And next bit. Let's start with this piece right here. Yes, gonna be like that. So inwards like a square. Put this on either side. You just press fit that downwards. Should hold. Second one, like this one, is going to be the back where you get the wire access and the power jack. It goes right next to that right here. It's right there. Like so. Going back to the parts from earlier, you should have these right here. This is the female and then the male power jack. And then you have a double-sided sticky tab. This male and female, you would need two male-to-male power jacks or jumper wires for the positive and negative. So just unscrew that, put them in and screw it back in. That's way too quicker. You can see right there, you just put them in. And then just tighten the screws. Make sure they're not loose. This one's a bit loose. Let me do it tighter. Better. Now this is going to go to your this one right here. They'll just plug in the power. You do that later. Now the next one, which is the female one, I'm going to do the same thing, just two male-to-male jumper wires. Make sure these are loosened. Make a note where the plus and minus is. If you look where the screws are, there's going to be a minus and a plus. Obviously ground and power. If you can, I suggest doing, say, red, brown, red, and black for power and ground. Since red's pretty easy, you know that's power. Or if not, just make a note, you know which one it is. Come on. Tighten that up. Okay. Now you have this Arduino breadboard jumper thing. It actually might be a tad too wide. I didn't realize they had the little tab right here. If you have it in front of you, you cannot see it here. Well, I bet you can. Try to cut that off somehow with a knife or scissors or whatever. If you have an exacto knife, that'll be perfect. That will be in the way. Since the one I used to measure it off, I didn't have the side tabs. There. That nice and clean. That should fit pretty good. I would just take off the sticky tab and put it down in the corner. Make sure it's closest to the gap right here, because this is where the wires access will be. Like so. Now if you take the female end jack, the housing will be right here. Put that in. Now make sure it doesn't fall out or get pushed out. This is why I gave you this. You just cut off a bit, a piece. Need. And just weld. Like so. Pull this out. Try to pull it out. And up. I'll just do it like this. So I have a tab. If you can, put it right here, about where the female end would go. And then do the other side. Want this out. Take out the tack there. and then just push this in. We'll make sure it holds. It will get loose eventually. That's why I gave you the tack, like so. And if you actually do this now, red, for example, I have red and brown, so red power, brown's going to be ground. Put those in first. Like so. And then you have the fun part, this. So this is going to go on the outside, other side of it. Press it in. Now, if you don't remember what side was ground, what side is power, if you go back here, let's do a better picture. Right here. As you can see from this picture, positive would be right here, which is going to be my green line. It's going to be the furthest or left one if you're facing from the back side, the flat side. Positive or negative will be the furthest left one, yellow. And then the middle line, black for me, that's going to be the signal. Don't forget, it has to be female, male for the power and ground, and then female, female jumper wire for the signal, as this will go to the Arduino pins. This is going to be power, so that goes to red. The yellow is going to be ground, so put that to ground. Put that to the side. And then you do the same thing for the next three. If I can get the snap in. That side's in. There we go. That side's in. So it's going to look like this. This is going to be the front, back, power, and then cable output. So let's start with this one. Number 2. Furthest right, furthest left, in case red will be power. Orange is going to be ground, and the middle wire is going to be data. So move all these wires out of the way. And move these as well. Normally, I'm a big proponent about wire management, but this is such a small case. It's kind of hard to make everything neat. That's that. Orange is ground. Next one. Brown is power in this case. And then black is ground. Blue I have as power. And then I have purple. Purple is ground. It's got to keep the data lines out of the way. That's buried in there. There we go. Put this out of the way. Like so. Next bit. Next bit will actually go to the robotic back again and wire that up. See, for the robot, for the gripper arm, I did it through the bottom, through these gap in here, out to the back. Just makes it a bit easier to manage with the wires. And the other three is really easy to do, except let them hang where they are. Now let's go back to the male to female end. You're going to need 2 of those, 2 of those, 2 of those, and then 3 of those. Going back to the gripper, we're actually using extension because it's so further away than the other 3. That's why we're using 3 of them. No. If you have tape, for example, I have electrical tape, I'm just going to wrap it around here to make sure it doesn't fall out. It doesn't slip. Okay. Then the next one, this is 1, 2. These. Now the next one, we're going to need the 2 male to female ends. That's going to go to your ground and your power. For example, this is going to be brown and black. I have that. Brown is going to blue, which is ground, and red goes to green, which is going to be power. So make sure you have the, that's the one. There it is. Make sure you have the 2 male to male ends. Yes, male to male, because they're going to the breadboard. I will have yellow as my ground and then orange as my power. And then for my signal, I'm going to need a male to female end. Which let's just do white since I have that. And then like before, I'm going to wrap this up in electrical tape once or twice. Make sure they're good. Okay, that's one servo. Let's go to the next one. We're going to need 2 female to female ones. I have green and blue again. So let's just do brown as blue for ground and then green as power for red. And then we need 1 male to female as well for the signal. Let's use gray. Base, same thing. Where are my wires? Nope. 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 Give me a minute. I need to grab some more wires. I apparently took too little. All right, for the next one, once again, ground and power, black and red. And then one for a signal. And then one final one. Okay, that's that. Now let's connect the servos to the power and ground of the actual hub. So blue, green, ground, power. That's gonna be fun. Let me strip those over. All right, that's one. And brown, red. Do two. This one is going to be yellow, orange. And then the last one, purple gray. It gets difficult putting all the wires in, jumpers in. It's kind of cramped in this housing. Just do your best as you can. And don't forget to make sure you have the signal cables away from main housing. Don't want that. Now try to put the wires inwards as much as you can. So it goes like that. And then this one, like that. Put the signal cables away. There. Next one, we have the male power going to the Arduino shield. That's going to be power and ground as well. So in my case, purple's going to be ground, gray is going to be power. Yes. If I can find a spot. That's one. Cannot see. Oh, come on. There you go. And that's power to the nano. Now we can do the cover. Make sure you know, starting with the signal cables for the knob potentiometers. These don't go through this first slot. The wires isolated. Try to make sure you know what wire goes where. For example, for the coding, I have that this leftmost knob, that's going to be 0, 1, 2, and 3. They goes to analog pins number 0, 1, 2, and 3. So try to keep these colors in mind if you can remember. In my case, I have black as number 4. Wiring hell. And it should be open. White as 3. I have red as 2. And then brown as 1. So I have to keep that in mind. Brown, black, no. Brown, red, white, black. And you just feed them through the first slot. Or so. Now you do the same thing with the other wires for the servos. It's only 3. Oh, here it is. So go over here. These go to the second slot. If I can get them in. we go. And what we do next is snap in the top. Okay, snap in the top. Just this side. Oh, I had the broken one. That's right. This one does not want to go. Oh well, that's good enough. All right, for the wiring for the Arduino Nano, that just fits right here. It's on a little slot. Doesn't, nothing holding it in, but it's on a little section. We're over. Now, like I said, why is this angled? Like I said, remember which wires came from where for the knobs. These are going to go to this bottom row right here, the first four, A0, A1, A2, and 3. If I remember correctly, black was supposed to be 4, white, red, and brown. There we go. And you can put these wires in more, so it kind of hides it. So it's kind of like that. And I do the same thing from the other side. Now remember, for our code, I never switched it. I had, where is it? Here it is. Oh, a bit more. For 8, that is going to be the rightmost servo, this one. 9 is going to be the leftmost one, this one right here. 10 is going to be the bottom servo, and then 11 is going to be the very gripper servo. This one right here. So just follow around the lines you did. Each orange line goes from what signal goes to that single one. So let me start with this rightmost one. I have orange going to black. Black's going to be 8. Right here. Make sure you do this bottom row closest to the nano. As you can see in the image right here, this row. Let me actually zoom out as well so you can see better. Moving on, you're doing the leftmost servo. Orange is going to gray. Gray slipped out. Gray is going to be 9. Then the bottom one, the base, orange is going to brown. Brown is then going to be 10. And that means that 11, the gripper servo, is going to be the final one. It also means that you can take this, the male end, plug it into the shield. So this has power. That's gonna be mainly it. Now for my kit, I have a slightly older one. Most of you guys, if you look at your top piece, you have this flat off. So you have a spot to put your Bluetooth module in. You can put it like that. Since mine's an older version, I'm just gonna put it to the side. Once again, just use the double-sided sticky pad. Where did I put the scissors? You can do it to the side as well if you want. Doesn't really matter. So let me put that right there. Then you have this right here. Put like that. Or so. Now all you need is 4 more wires. You need 2 male to female and then 2 female to female. Like so. Now if you look back to this right here, as you can see, TX, that's going to be this bottom one. Then you have, no, that's RX. TX is the second one after that. Then you have ground and power. Pretty sure that's right. Yes, it is. So as a repeat, first one you ignore from the top. Second from the top, that's going to be your power. Third one's going to be your ground. Then you have your TX, then you have your RX. So let me do red and orange as my power and ground. There we go. Then I'm going to have white and purple as my 2 signal outputs. Now, white is going to be TX. That's going to go to pin 1. It's actually labeled 1 and is TX. Now, you can move these pins later, depends on your code. You can make them, for example, pins 6 and 7. But since they already have a dedicated pin, I'm just going to leave it as there. The RX purple is going to be pin 0. And then power and ground. Oh, that's a lot of wires. Power and ground. Let's see if I can fit this in somewhere. Okay. And then, okay. Well, it's finished. Kind of. You can angle that. Wow. All he has to do is just power it on and then run the program, which I'll do right now just in case you guys know. Camera, where are you doing? So like the first time, what you do is take your USB to Nano, plug that in, and go to the code I sent you. It should be called manual control, I believe. Let me actually look it up. Yes. It's called manual bot control. As you see, I have the library servo that comes with the Arduino library, and I have 4 servos. It's 0, 1, 2, and 3. Then for the pop pins, those are going to be your analog signals where each potentiometer will be. And set those pop pin values, the analog value, to each value right here, value 0 to 3. That's just setting it up. The next part is we have to attach each servo we set up to each pin. So servo 0, which is going to be our rightmost servo, that's attached to pin 8, and so forth. The next part is just going to be the repeat of the code, more or less. You have the first servo 0. You set analog read. It's reading what's the current value of the analog from 0 to 1023. And it constrains that value to 90 degrees to 175 degrees. And it maps that value to val 0. Then val 0 is being written from the data line to the servo and delays it by 15 milliseconds. And actually compile that. It's not compiling now. Make sure you remember that you have set to Arduino Nano, the old bootloader, and whatever your new COM port is. And you just do upload. Uploading is done. Now I can just unplug or unplug this. Then you just take the power cord that should be in the pack and plug that into the female end. Look at it right there. Then let me actually plug it in. Now I have everything set to 0, 0, 0. You'll see this move the base 190 degrees. Since 0 degrees is going to be right here. This is currently at 90. If everything is done right. There we go. If you notice, my actually bot is slightly off from the base. That means I just need to take off the base and put it at where 0 would be. I must have moved it by accident. So many wires. Are you in? You are not in. You are in. There. So then, if I slowly move this one, kind of hard to see. Let me actually turn the base. There we go. Now these potentiometers are kind of cheap, so they're not the cleanest and signal-wise. And you have to be very careful when you move them, because if you do too quickly, the program doesn't understand you want to do slowly. It just understands, hey, I need to move this at this position. So it immediately goes there. It moves about 60 degrees every 0.25 milliseconds or 25 milliseconds. So if you program this on your own, what you can do is say, tell this to move only so many degrees every second. It'll read you want to go to this position, but then just slowly move it. It's the same process I have to say, I slowly move this right here. Now remember, this position is going to be moving this base. This middle one is going to move that one. The furthest one's going to be the base, and the back one's going to be the gripper. One of my parts fell out, so the gripper isn't going to work. You need to fix that. But besides that, that's going to be the main part of it. Any questions?
Nope, I'm still a bit of a ways back in assembly here, so.
That's all right. Yeah, I had a few experience making these, so I'm quicker than most. What I do suggest is if you have this bot here, it's picking something up and it's quickly turning, it has a tendency to tip over. That's because there's just so much weight up here and it's very light here. What I did is my first design, my first test, I screwed it onto a board, like so. Okay, hold on. Nope. So my camera freaked out. Eeh. Well, is what it is. Okay. Let me just move back there. Now, while people are building their bot currently, if you have any other questions, for example, of the code, or for example, future programs with a Bluetooth module, just let me know. So it is 1:30, and I do have to get going to a meeting soon. But I will post this full video, 2.5 hours full, and give updates if you have any questions. If you have anything now, please ask so we can answer it.
Thank you, Andre.
Yeah, thanks.
All right, then I'm going to pause the meeting.